Guys, welcome back to another video. In today's video, we're going to be doing electrostatics, right? So when we're doing electrostatics, we first have to look at our examination guideline. So when we're doing electrostatics, we first have to look at our examination guideline, right? Because if we're going to have some definitions that we will have to define in the whole topics, and it also gives us an idea of what we are going to be using while we are solving for this topic, right? So they say state Coulomb's law in this manner, right? So the magnitude of the electrostatic force, firstly, we need to understand what is the magnitude. When they say magnitude, which is this word right there, they're talking about size, okay? So in physics, they like to be fancy, as you guys know. They like to be fancy, they like to use big words for no reason. But when they're talking about magnitude, they're talking about your size, okay? Of the electrostatic force. What is an electrostatic force? Guys, in physics, if you're not going to ask yourself these things, then you're not going to understand. Because now, here you are stating a law, right? But now, if there are words that you don't understand, how are you going to understand this law? How are you going to grasp it? You're just going to memorize it, know it, and then after 2 weeks it's gone. No, you need to understand it. And by the way, how do you understand it? You understand it by knowing what does these words mean. So an electrostatic force is a non-contact force of attraction or repulsion between stationary electrically charged objects. Right. So what does that mean? It means that if we are having 2 points, these are going to be our object, right? So the force, it is going to be a force of attraction or repulsion between these two stationary objects, right? And they have to be electrically charged. So that force between these two objects, it is going to be called an electrostatic force. Now, it is extended by 1 point charge. So if we are going to give this objects names, we're going to call this one Q1, and then this one is going to be Q2. So it is going to be an electrostatic force that is going to be extended by 1 point charge on another, which means that this one is going to affect this one. So Q1 will affect Q2 and Q2 will affect Q1. Okay, so they say that it is going to be directly proportional to the product of the magnitude of the charges. So our force, right, it is going to be directly proportional, which means we are going to have our charges here. So this is going to be Q1 and Q2. So what does that mean? What do they mean when they say directly proportional? They mean that if this one increases, then this one will increase as well. And then they go on and they say it is going to be directly proportional to the product of the magnitude of the charges, which is what we wrote there, and inversely proportional to the square of the distances between them. And then they go to tell us that it's r. But we don't just put r because they said to the square. So when they say square, it means that we're going to say r and then we put a 2 there, right? So this is what they meant in our formula. But we also have a constant, which is going to be k. So now we put that k, just like this. So now we are saying that the magnitude, which is the size of our electrostatic force, is going to be extended by 1 point charge, which is this charge right there, 1 point charge on another charge. It is going to be directly proportional, right, to the magnitude of the two charges and inversely proportional to the square of the distances between the two charges. So guys, if you look at the formula, you can state Coulomb's law by just looking at the formula, because you know that your force, right, the magnitude of the force is supposed to be directly proportional to this 2, and it has to be inversely proportional to this 2. But of course, you need to use those words that they use, like power physics, which is extended by, right, on another point charge, directly proportional to the product of the magnitudes. Can you see those words? You need to use those words of the charges and inversely proportional to the square of the distances between them. Now, how can you catch definitions? How do you understand definitions? By doing exactly what I just did to you. You break down the definition, you understand the words. Someone didn't know what was the meaning of magnitude. Now you guys know its size. Electrostatic force, it is a non-contact force of attraction or repulsion. Now you can ask yourself, what do I mean when I say it is a non-contact force? Because these two charges can attract each other. So how is it a non-contact force? Because if they attract each other, they are going to be on contact. Well, it's very simple. For a force to be a non-contact force, it has to act without the object physically touching each other. So this object can act without this object touching it, right? So what do I mean? If this one is going to have a positive charge and this one is going to have a positive charge, they're not going to touch each other, yet they are going to have something happening between them, right? So that means that for these two objects to have a certain movement, they don't need to touch each other. Therefore, that's why we say it is a non-contact force, which is a electrostatic force. It is a non-contact force. For the force or for anything to happen here, or for the object to move, then they don't have to touch each other, right? That's what we mean. And we also have other forces that are non-contact, which is your gravity. For gravity to act, it doesn't have to touch you, right? That's why when you fall off something, you're just going to fall. It doesn't have to touch you. It can just act on you automatically. We also have magnetic force. If you have two magnets, which is the same example that I just made there. So this is magnet number one, magnet number two. For these two magnets to act, they don't have to touch each other, right? But now, what are forces that are contact forces? Because now I've given you examples of forces that are non-contact. Now, if we're going to talk about contact forces, then now we are talking about your friction. For friction to act on an object, these two has to be in contact. If we're going to be pushing a box on a friction surface, so in a surface that has friction, then this box is going to be slowed down. It is going to rub against this surface and then it's going to be slowed down by friction. Now, if we did not have these two touching each other, nothing was going to happen to the box. If the surface was not touching the box, nothing was going to happen to the box. Now, because they are touching each other, then friction is going to act. Now, that is a contact force. What about your applied force? For objects to move, if we are going to push an object, maybe an object is in our table, for us to push the object in this direction, we have to add a force that is going to push it. Now we had to be in contact with the object for the object to move. Now that is going to be a contact force. I hope you guys understand the difference between the two. I don't think they're going to ask you about it, but they can ask anything in the examinations, right? So we are going to have different formulas that we are going to be using, and then they tell us that we need to solve problems using the equation, which is this equation right here, which is the equation that I gave to you while we were busy with our definition. So if you see the equation which you are going to be given, then directly like that, you are going to know the definition by just looking, because you know that something has to be directly proportional, and that's something, it has to be a force. It is directly proportional to the magnitude of the charges, and indirectly proportional or inversely proportional to this to the distance, right? To the distance between them, right? So this is going to be our formula, and then the other formulas that we're going to use is this one and this one. And then they also tell you for which formula you're going to use for what. For example, this one you're going to use it when you're calculating your electrical field, and then this one you're also going to use it when you're calculating your electrical field. But now you know that you are given, when you are, sometimes you can be given different data, right? So if you are given, for example, if you are given the data that fits this formula well, then you are going to use it. But if you are given data that fits this formula well, then you are going to use that formula. I hope you guys understand the basics and you guys now know the things that you should apply. Now, okay, but before I speak about that, let's go to our formula sheet. So in your formula sheet, in your electrostatic part, this is where you are going to find your formulas where you're going to use for electrostatics, which the formula that I gave to you, right? And then also we have this one. These are the most common formulas that you guys are going to use, right? It is going to be 1, 2, 3, 4. These are the most common formulas. And then that constant that we spoke about, which is K, right? We spoke about this constant. Where do you find that constant? Well, when you go to your data sheet for physical sciences, you're going to see Coulomb's constant, and then it is going to be 9,0 times 10 to the power of 9, and then they also give you the SI unit right there, right? And then now charge on electron. Charge on electron, you are going to use that when you are dealing with this formula, right? Because now you are calculating for the number of electrons. So you are going to use that. So you're going to use charge on electron, which is this one, which is going to be 1,6 times 10 to the power of negative 19. But most one that you are going to use is going to be this one. So I suggest that you know it, it is there on your data sheet, but just for saving time during your examination. And the only way you can know this in your aid is by practicing and doing questions on it. All right. So we can add another formula here that is not here on our formula sheet, which is going to be when they ask you to determine what is the charge going to be on each after they have separated. And we are going to deal with those questions in the following videos. Please make sure that you check that out because we are going to be dealing with it. So we have Q1 plus Q2 divided by 2. That is going to be the charge each object is going to have after they have separated. Because remember, if this one is going to be if we are going to have two different charges, if we are going to have Q1 and we are going to have Q2, these are our different charges. If this one is positive and this one is negative, they are going to be in contact with each other. They are going to attract and be in contact with each other. Now, after they have separated, if we separate them again, this is what this formula means. Okay, and they are going to ask you a question like that. You're just going to use this. It's very simple. Okay, so I hope you guys understand the basics. And then also another thing that you guys should know is know how to convert. And this is what I'm going to teach you now, because a lot of times you find that children don't know how to convert. Okay, so firstly, you're gonna write at the top at your examination paper. Understand? You're going to write this. So you're going to say times 10 to the power of negative 3, and then you say times 10 to the power of negative 6, times 10 to the power of negative 9, times 10 to the power of negative 12. Now, can you see there's a pattern here? 3, 6, 9, 12. It is a pattern, right? It's very simple. It's a pattern. Now, if you were in a class and then your teacher told you to keep quiet, you could close your mouth, but still you can be loud with your brain. You can think about anything. All right. You don't need permission to think, just like when you need permission to speak in your classroom. You can think anytime, anywhere, whenever, when you need to think, right? So you do not need permission. So what can we say about our minds? We can say minds, right, which is going to be M, never need permission. Minds never need permission. Right, and then you come and then you are going to put them here. So it's going to be M, and then it's going to be that it looks like an N, but it's not an N. And then we have an N here, which stands for nano, and then we have P for picocoulombs, right? And then you're going to put your C's. Can you see? This is you converting back to coulombs, because each and every time when you are going to use this formula, you are supposed to use it, everything is supposed to be in coulombs, right? So each and every time when you are going to use F equals to K Q1 times Q2 divided by R squared, those, they have to be in coulombs, right? Now, for us to convert back to coulombs, whatever, if we are given MC, we are going to times whatever that we have with 10 to the power of negative 3. Please know this. Now you can know it by using this. Minds never need permission. And then you write it like that, because they can ask you in any way. And the one that they like most is this one, NC. They also like MC, right? These two, they like the most, but you need to know everything, because you don't know which one they are going to ask, right, when it comes to you. And when you use this formula, of your force equals to K, which is our constant, Q1, which is charge 1, Q2, you do not write the signs. You do not include the signs when you are using this formula right here. So you are going to be given this. They are going to have different signs, right? Because they are charges. They need to have a sign. It can be positive, it can be a negative. You do not include that negative here. So you are just going to write them straight like that, right? So if you are given a negative 5 for Q1, it's going to be negative 5 coulombs for Q1. And then let's say we are given 10 coulombs for Q2. So how are we going to write it here in our formula? I am saying to you that you do not include the sign. So you're just going to put 5 coulombs here. You do not put the C, but it's 5 coulombs. And then here you're going to say 10. Okay, that's how you're going to write it. They have to be in coulombs. If you are given anything in this form, for example, let's say we are given something in nanocoulombs, which is this one. So they say, let's say they give us a question and then they say, for example, you are given negative 3 nanocoulombs, right? You know that you have to change this into coulombs. So you are going to look back on your, because I said you have to write this, right, on your exam sheet. They're not going to give you this. So you write this on your question paper, right? And then you are going to say, oh, I know it has to be times 10 to the power of negative 9. All right, and then you come here, and then when you are writing, when you are putting everything in this formula, you are going to put negative, you don't put the sign, so you are going to put 3 times 10 to the power of negative, what is it, negative 9. And then you are going to add other things that you are adding, but I'm just showing you that's how you are going to write it. I hope you guys understand, and I hope you find this video very much useful. Please subscribe so that you can get more videos coming from us, and hit that bell notification so that you're notified each and every time we drop a single video. Thank you.